Hello, I'm WP Suazo, and I'm here to talk to you about allocative efficiency and the production possibility curve. Um, Imagine we have a factory that works with styrofoam, making both styrofoam coolers and styrofoam helmets. The factory can make all coolers, 64 coolers with no helmets, or it can make all helmets and no coolers. If you look at the numbers, and we shall do that right now, the difference in helmets is 4, always 4. And for other examples, it could be 3, it could be 5. But if we look at the difference in the other product, which is coolers, we'll see that those differences change. And the message from this variation in the numbers is this: as we start with all helmets, making only helmets, and we want to make coolers, making coolers means sacrificing some helmets. So the first 4 helmets we sacrifice, we get a whole bunch of coolers in return, 28. But then if we make that same sacrifice again, sacrificing 4 more helmets, we only get 20 more coolers. What this shows is the law of diminishing returns. And all this means is that resources are not the same, they're different. Okay, looking at these numbers, the difference in helmets going across is always a difference of 4. The difference of coolers starting from A to B is a difference of 4 only in the beginning, in the first interval. But then it becomes 12, 20, and 28. So if we look at all the numbers in between, we ask ourselves the question, okay, what number do we see the most? And the number we see the most is the number 4. So if we divide all these numbers that are in the gaps by the number 4, here's what we get. 4 divided by 4 is 1. 12 and 4 is just another way of saying 1 to 3, or let us say 3 to 1. And 20 to 4 is another way of saying 5 to 1. And 28 to 4 is another way, this here is 28 to 4, another way of saying 7 to 1. All right, so what these trade-offs represent is what is happening on the factory floor. But the factory wants to make what is popular in the store. So to find out what is popular in stores, we need prices. Okay, so beginning with prices, let's say that we have coolers again and helmets. Let's say that coolers are selling for $5 and helmets for 10. If that is the case, and let's say that we always have enough money to buy 1 helmet, that makes this trade-off here 2 to 1. If you look at our trade-offs here, we see that, well, overall, coolers are more abundant than helmets. So all these 1s here represent 1 helmet. And these bigger numbers represent coolers. All right. So what we have here is, according to the stores, we have 2 coolers having the same worth as 1 helmet. If a bicycle helmet costs $10 and a cooler $5. So you could take these dollar values and multiply them off the quantities here and get totals. Now, for example, with helmets, we didn't make any helmets at point A. We have coolers being worth $5 a piece. So this would be $320 when coolers sell for $5 and helmets sell for 10. If we look over here, if we make 60 coolers and 4 helmets, we would get $300 from cooler production when they are being priced at $5 a piece, plus $40. So here we would have $340 versus $320. Point B is worth more than point A. But to avoid all of that, a simple shortcut is to ask, where does 2 to 1 fit among 1 to 1, 3 to 1, 5 to 1, and 7 to 1? And we see that that fits best right here. So when coolers sell for $5 a piece and helmets $10 a piece, the production goal that is worth the most money is production goal B. All right. In the stores, in the marketplace, let's say things change. And let's say coolers are still selling for $5 a piece, styrofoam coolers, but now styrofoam helmets are going to sell for $20 a piece. So if I have enough money to buy a helmet, I can afford one helmet. I can afford one helmet, or I can afford 4 coolers. So now I have one helmet to 4 coolers. All right, with a $20 bill, I can afford one helmet or 4 or $5 coolers. So here I have 4 to 1. So with our first example, we were at point B. If the price has changed to now this, the first question is, do we adjust towards all coolers, which is right here, or to all helmets? Well, if helmets have increased in value, we should be heading in the direction of all helmets. But do we go all the way to all helmets? Point E represents all helmets. And to get to point E and pass through point D, you have to give up 7 coolers to get one helmet. Imagine that. Imagine getting one $20 helmet by giving up 7 $5 coolers. That would be getting $20 by giving up 35. And that would not be worthwhile. So that would be too much. So the best adjustment would be this. If you were at B, we adjust only to C because 4 to 1 fits best between 3 to 1 and 5 to 1, not between 1 to 1 and 3 to 1, or 5 to 1 and 7 to 1. So that fits best there. If you wanted to take these prices of $20 for a helmet and $5 for a cooler and multiply them off these quantities and add up what they're worth, you would soon see that point C is worth the most money. Okay, let's have a big change in prices. Let's say that coolers are going to double in value to $10 and helmets are only going to be worth $9. If we have enough money to afford a helmet with $9, we can afford one helmet. But using $9 to buy a $10 cooler, we would only be able to afford 0.9 of a cooler. So we started at D, we migrated to C. Where do we go now if this is the latest thing the marketplace says? Well, if coolers doubled in value, while helmets lost some of their value, we've been migrating so far towards all helmets. Now it's time to go back in the direction of all coolers. Do we stop at B or do we go to A? Well, if this is 3 to 1 and that's 1 to 1, 0.9 to 1 would fit right here at point A. As you can see the transition, 7 to 1, 5 to 1, 3 to 1, 1 to 1, 0.9 to 1 would fit best right here at point A. All right, let's go back to $5 coolers. Now we're going to have $30 styrofoam helmets. So styrofoam cooler for $5, a styrofoam helmet for $30. If I have enough money to afford the helmet, I can afford one helmet or 6 coolers. So where does this fit? Among all of those factors, this is the marketplace trade-off. Those are the factory trade-offs. And as you're thinking at point D, 5 to 1, 7 to 1, 6 to 1 would fit best right there. If for our final example, we have, let's say helmets selling for $40 With $40, I can afford one $40 helmet or 8 $5 coolers. Now we're going to have 8-to-1. 8-to-1 factory trade-off blends best right here at point E. Now, I misspoke. This would be a market trade-off. It fits best amongst the factory trade-offs right here at point E. Because we'd have 3-to-1, 5-to-1, 7-to-1, 8-to-1. The economy doing what people want in the marketplace as reflected by prices is what fulfills allocative efficiency. I hope this has helped you understand the production possibility curve and allocative efficiency. Look for my other videos under my name, WP Swaza. And thank you for watching.